Okay, in this lesson we are going to look at what is known as integration. And integration is really the act of undoing a derivative. So looking at our formulas, if I took the derivative of some constant, we know we get 0. So if I integrate 0, I get some constant. And notice we go through here and looking at each one of these rules, we see how we can in turn go back to our integration. So here, if I did the derivative of individual terms, notice I can integrate those individual terms. So let's put this into some practice here. In general, here was our power rule where we multiplied our exponent down and then subtracted 1. So to undo that, over on this other side, we would add 1 and divide. Now this plus c that's sitting there, that's there in case we had a constant we did the derivative of, but we don't know what that constant is. So up here in this case, notice the derivative of a constant was 0. Well, we don't know if we had other stuff added out through here, and when we took the derivative, it ended up 0. So this is kind of a placeholder for those constant values, so we say plus c. All right. Looking at this first example, this is telling us that we need to integrate 7. In other words, if we took the derivative of something and got 7, what was that something? What was it originally? Well, hopefully we say, it was probably 7x, and we're going to put a plus c to hold that place of any constant, and this would be our final answer. Now, if you don't see right off that, hey, it had to be 7, you could rewrite this integral to be 7x to the 0 power dx, and if we add 1 to our exponent, remember that would be 0 plus 1 over 0 plus 1, and once we simplify, notice we get 7x, just like we did earlier. So looking at it, if you can reason through it, that would be great. Now, a way to check to see, well, is that correct? Well, what is the derivative of 7x? Well, it's 7. What's the derivative of some constant? 0. So notice we got 7 back. I'm looking at number 2. Same idea here. I took the derivative of something and we got x to the 5th. Well, this one might not be as easy as number 1. So let's employ our rule here. We're going to take x to the 5th. We need to add 1 to it, and then that tells us what to divide by. And then, of course, we have our plus c. And if we simplify, notice we get x to the 6th over 6 plus c. And that, again, would be our final answer. And so looking at number 3, again, same idea, and hopefully we see we would get x to the 13th over 13 and then plus some constant c. Okay, number 4, now we have problems a little bit more involved. Just like we could take the derivative of individual terms if we're adding and subtracting, the same is true for our integration. We can divide this up and have something that looks like this. And then we go through and we integrate our individual terms. We're only going to write plus c once because a constant plus a constant is still some other constant. We just don't know what it is yet. And so if we integrate this first one, we add 1 to 4, and that's what we divide by, minus, add 1 to 2, and again, that's what we divide by, and then we have plus some constant c. And so the same is true with 5. We would divide this up, and if you want to skip the step of dividing up, you're welcome to do so. You don't have to write all this out. I would encourage you to look at if we integrate 1 dt. That usually gets people. So here if we integrate t cubed, we know we add 1 to the exponent, and that is what we divide by, plus t squared over 2 plus, well, what did I have to have here in order for me to get a 1 when I did the derivative? And it would just be t, or x if our variable was x, and then plus c. So don't let this integral of 1 fool you, and it usually trips up a lot of people. Alright, and for our last problem, well, what do we do with that 3? A lot of times, if you have a constant, you can move that constant out. So we're really looking at, and I'm going to change colors so these don't overlap. So I'm going to move that 3 out and look at 3 times the integral of x cubed dx. So that's going to be 3 times whatever we get when we integrate. Well, remember when we integrate, we add 1 to the exponent, and that's what we divide by. And then plus c. And so you can rewrite this. You would either see your answer written like this, or you could see 3/4 x to the 4th and then plus c. Okay, and again, more practice. And so let's see if we can do some of this in our heads, see what we can do to save ourselves some time. So we know we can integrate each individual part since this is subtraction. And so I'm going to have 2x, add 1 to the exponent and divide, minus 7x squared over 2 minus, and that would have been just 8x, and then plus c. And so from there you would need to recognize your answer choice. Okay, now number 8 is looks like it might be a little more difficult. So let's see, it's got a lot of fractions in it. And again, I would just keep here 3/4 x to the 6th divided by 6. Now remember, you are multiplying these terms, plus, and we have 5/3 x to the 3rd divided by 3 minus, and then remember x over 2, that's really the same thing as 1/2, isn't it? And then x to the 2nd over 2, and then plus c. And now let's do some simplifying, or here you would just look to see where you could find your answer in your multiple choice if this was multiple choice. So I would cancel the 3 and the 6. So let's see, you're going to have x to the 6th over 8 plus, let's see, x to the 3rd, and let's see, gosh, that's going to be a 5x to the 3rd over 9 minus, looks like x squared over 4, and then plus c. So notice you can save yourself some time with all the rewriting. Now number 9, I love number 9. It's a great example of how we tend to mistake pi for some kind of variable. Pi is just a number. We would treat it just like we would 2, 3, 4. And so, and I'm going to move this down here so I'll have a little more room. If I integrate pi x, that's like integrating 3x. So I had pi already there, times x, and we add 1 to the exponent and divide, plus, and again, 1 over pi is just a number. So what was that to begin with? Well, it would have been 1 over pi x. So to simplify this a bit, we're going to have pi over 2 x squared plus x over pi or 1 over pi x, either one, and then don't forget your plus c. Okay, with these problems, this is just like how we had to do some rewriting when we went through our power rule. So we're going to have some rewriting here. so let's rewrite this to be the integral of x to the negative 2 dx. Now when we add 1 to our exponent, please watch your signs. That's going to be negative 2 plus 1 over negative 2 plus 1. And then of course plus c. So notice I get x to the negative 1 over negative 1 plus c. And we don't leave negative exponents. That's one of the few things we do need to simplify. So this is going to be negative 1 over x and then plus c. Okay, moving on to 11. Same idea. And I would go ahead and just start rewriting this. So I know this is going to be 4x to the negative 3 plus 1 over, well, negative 3 plus 1 is negative 2. I have minus, and 5x to the negative 4 plus 1. Well, that's going to give me negative 3, and then plus c. And so let's see, that's going to be negative 2 for my coefficient, and then x to the negative 2. So I'm going to go ahead and flip that over. And then let's see, this minus here is going to cancel with that. So I have a positive, isn't that great? And then 5, and then that's x to the negative 3. So let's move that to the denominator, plus c. Okay, and now for this next one. And this is square root, so we have to remember, well, what exponent means square root? That's going to be x to the 1/2. And again, remember, we are adding 1. And that tells us what to divide by. So 1/2 plus 1, well, that's going to be 1.5. Or let's see, what's that going to be? 3/2, isn't it? And then plus c. And so I have, let's see, that's going to be 2/3 x to the 3/2, and then plus c. Okay, and continuing on, we still have the same pattern here. So let's see, if we integrate, and we're going to do individual terms here. So that's going to be 2, and that's y to the 1/3 plus 1 over, well, 1/3 plus 1 is 4/3. And then minus 4y to the 1/4 plus 1, well, that's going to be 5/4. And then, of course, plus c. And then as we continue this, if we need to flip and multiply, so 3 times 2, 6/4, which is what, 3/2, y to the 4/3. And this you're welcome to leave, minus, and then if we flip here, that's 16/5 y to the 5/4, and then plus c. Okay, and for the next one, and I'm going to change colors again because this can get pretty messy with all this. Okay, so let's see, we have here x to the negative 1/2 plus 1 over, well, negative 1/2 plus 1 is positive half. And then we have minus x to the 2/3 plus 1 over, well, 2/3 plus 1 is 5/3 plus c. And let's see, if we simplify this, we're going to have 2x to the 1/2 minus 3/5 x to the 5/3, and then plus c. So this looks absolutely terrible, but it's okay. We can do this. Okay, and of course for the number 15, they're going to throw pi in here. And again, when they throw pi at you, get a fork and eat. No. You're going to go through and treat it just like you would any other number. So really this is x to the pi plus 1 over pi plus 1. And then plus, well, that's square root of pi. All of that's still a number. This is just a coefficient. So really that was square root of pi and then x and then plus c. And there's really not much more you can do with that. I do want to write that a little bit better. You're going to have x to the pi plus 1 over pi plus 1. That's what that one was. And then plus square root of pi x and then plus c. Okay, so sometimes it's not going to be as straightforward as we would like whenever we're doing our integration, and you all, I'm sure, kind of expected, hey, it can't stay this easy, and you are absolutely correct. So there's different tricks, and this is where we're going to need some algebra to rewrite some things. For instance, here, well, we can't do the integral of each individual term because it's all raised to the second power. But what we might could do in order to rewrite this is say 2x minus 3 times 2x minus 3 and do some fooling here. And so we're going to get 4x squared. Now don't forget your middle term. You're going to have negative 6x minus 6x, so minus 12x plus 9. And now we can go through and we can integrate all of this. And then we can go through and find that final answer. So we would have 4x to the 2 plus 1 all over 2 plus 1, or 3, minus 12x to the 1 plus 1 over 1 plus 1, plus 9x plus c. And then you can do some simplifying here. That is 4/3 x cubed minus 6x squared plus 9x plus c. So that's one of the, what they're calling here, a bag of tricks. It's just, you might have to readjust some of these in order to make them work out a little bit better. For 17, here's a great example of remembering your exponent rules and dividing this up and putting each term, and this only works if you have one term in the denominator. Now it would not work if you have more than one term. If you were adding or subtracting something in the denominator, don't try this because you just gonna make a mess of things. But like it is, we can say, well, this is really x squared over x to the 4th plus 3x over x to the 4th plus 1 over x to the 4th. And you can look at all of this and integrate it this way. And then that in turn, if you will go through and then simplify, it'll make it a lot easier for you before you integrate. So let's go ahead and simplify here. And keep that negative exponent because you know it's going to be 2 minus 4, because it's always the top minus the bottom, so 2 minus 4, negative 2, plus, and then this is going to be 3 to the negative 3, again top minus bottom, or 1 minus 4, plus, and then that's going to be x to the negative 4 dx. Now let's go through and do some integration. So that's going to be x to the negative 2 plus 1 over, that's going to be negative 1, and then plus 3x negative 3 plus 1, which is negative 2, plus x to the negative 4 plus 1, which is going to be negative 3, and then plus c. And then from here, let's see, if we simplify, we're going to have negative 1 over x. So we get x to the negative 1, and then the negative 1 in the denominator makes the whole thing negative. And let's see, we're going to have minus 3 over 2. And that x is going to move down to the bottom and be x squared. And let's see, minus. And it looks like we're going to have 1 over 3x to the negative 3, and then plus c. So that would be our final answer there. So watch those signs. Okay, number 18 is going to be a mixture of both of these. You will need to go through and fill this out, and then you need to divide up each individual part and do your integration from there. So let's go ahead and multiply out the top, and then we'll put it over the bottom, and I'll bring down this integration stuff here in just a minute. For the time being, I'm just going to ignore this. So I'm going to have 6x squared. Let's see, 4x minus 15x, so minus 11x minus 10. And then I'm going to put each term over x to the 1/2 power, because that's going to imply the same thing as the square root of x. Now I'm going to do some rewriting. So this is going to be 6x, well, 2 minus 1/2, that's 1.5 or 3/2. And then minus, and that's going to be 11x to the negative 1/2. And then here minus, and that's going to be 10x to the negative 1/2. Now I've not integrated anything. I've just gone through and worked through some algebra. Now it's time to integrate this mess. So looks like we're going to have 6x, well, 3/2 plus 1 is going to be 5/2, and that's going to be over 5/2, minus 11x negative 1/2 plus 1's positive 1/2 over 1/2, and then minus, and the same is true here. Let's go back. That's a positive 1/2, isn't it? I made a mistake. Uh-oh. So sorry. So that's going to be 3/2, isn't it? Over 3/2. Glad I found that. I thought that was weird. All right. And so we have minus 10x. And if I add 1, I get 1/2 over 1/2. And then plus c, because I've integrated. And now let's see if we can't simplify some of this mess. That's going to be 12 over 5 x to the 5/2 minus, and let's see, that's going to be 22 over 3 x to the 3/2. And let's see, minus 20 x to the 1/2, and then plus c. Right, and now we're going to talk about trig. And notice here we have all of our differentiation formulas, and if we integrate cosine, well, we get back sine, because that's what we took the derivative of. I encourage you to learn a nice little rule, and I've written it up on the board a few times, but as a great reminder for us, we do need to remember, and I would do this, you have sine, cosine, negative sine, negative cosine. And when you move this direction down, you're finding the derivative, but if you're moving this direction, you're finding the integral. You're undoing that derivative. So that does tend to help us remember, especially which ones are positive and which ones are negative. But there's all of the different formulas for you to memorize. Okay, so here for the first example we have with trig, we have 4 sine x dx. So again, anytime you have the constant values, you can move those out. And think of this, and you won't have to write in all these steps, but you need to think of this as 4 times the integral of sine of x dx. And again, if you remember sine, cosine, negative cosine. And down is derivative, up is integral. So if I'm going to find the integral of sine of x, well, that's going to be 4 times, and I need to move up. So this is going to wrap back around to here. That's going to be negative cosine of x plus c. And that would be it. So for the next one, same idea. I would move that constant out, and the constant, and that's sometimes hard to see as well, it's going to be negative 2/3. I'm going to move that out to the front and then integrate cosine of x dx. And then from there, remember again, if I integrate cosine, if we look at our chart, we're moving up. Well, if I integrate cosine, I get sine. So I have negative 2/3 sine, and the negatives because the negative in the problem itself, sine x plus c. Okay, moving on to the next one. Now, oh my, cosine squared. We don't know much about that, but we do know 1 over cosine squared. So let's move that 5 out, and that's going to give me 1 over cosine squared x dx. And if we remember our trig identities, which we usually don't, 1 over cosine squared, we just don't use them every day. That's going to be secant squared x dx. And if we integrate secant squared, that's going to give us tangent x, and then plus c. So if we remember these facts, then it's going to make these answers a lot easier for us. Okay, and continuing on, just like the other patterns, we can divide up. And so we really can think of this as 4 times the integral of cosine of x minus 9 times the integral of sine of x. And then we go through, and I forgot my dx's here, and I always forget that. Y'all don't forget them like I do. Okay, and now let's see, if we integrate cosine, and again, remember you have sine, cosine, negative cosine, and now we're moving up this chain. So we have 4 times, well, if we integrate cosine, we get sine of x minus 9 times, if we integrate sine, we get negative cosine x, and then plus c. And notice here we have a negative and this negative. So let's go ahead and simplify this. So we have 4 sine x plus 9 cosine x plus c. So hopefully that helped in the little chain. All right, so goodness, looking at this next one, that one, I'm not real sure what we can do with that one right off, just looking at it. It looks terrible. So let's see what we might can do. Well, I'm going to move the negative out because I really don't want anything to do with the negative. And so I have negative integral sine of x over cosine squared x dx. And let's see, that cosine squared means that there's 2 of them there. And let's see, do we remember that, let's see, sine of x over cosine of x, that's probably tangent x. We haven't looked at that in a while, but that's what that is. So let's divide up and say, okay, one of those cosines is going to go with this sine, and it's going to make a tangent x. And then I'm going to have a 1 over cosine left. Well, 1 over cosine, that is secant. And I think we might have found us one of the answers. So if we integrate tangent x, secant x, pretty sure that comes back to being secant x. And then don't forget your plus c. Okay, and this next problem looks absolutely terrible. I understand. But think about if we thought of theta squared as just an x squared, well, I guess I need to tell it to write, as x squared, well then it's not just terrible, is it? So if we integrate x squared, remember, well, good golly, that looks terrible, doesn't it? Let's make that look a little bit better. If we integrate x squared, well, we add 1, and that's what we divide by, right? So same idea here. theta squared, well, that's 2 plus 1, so that's over 3. And then I would move that 2 out, and if I integrate cosecant squared, I want to say that's going to be negative cotangent theta. And then we have our plus c. And then we need to go through and simplify this a little more. So we have theta cubed over 3, and that's going to be plus 2 cotangent theta, and then plus c.